Can y'all see?
Yes.
Yes.
Okay. So she's pulling a wagon on a horizontal surface with a force of 50 pounds. So, so this wagon is being pulled this way with a force of 50 pounds. Okay.
Mm-hmm.
And the handle of the wagon makes an angle of 30 degrees with the ground. So, you know what? I'm gonna go ahead and really quickly turn this a different color. Okay, turn that blue. And I'm gonna draw the handle in blue as well. It's a little handle. Doo, 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 doo. And we said that this handle creates a 30-degree angle, right? So let's see what else is going on. What is the magnitude of the effective force pulling the wagon? Okay, so the reason that this one is a little bit different from the first one is because if you think about the first one is different because the force is being pushed down. Okay, so when you're talking about the first one, you're talking about negative whatever something j. Here, when we're talking about this vector right here, we have a vector of 30 degrees, right? And we also have a vector of magnitude 50 pounds, but this vector is not being pulled straight up and down. It's actually being pulled to the side. Does that make sense? Mm,
Can you explain that again?
yeah, okay. So when you're talking about movement and forces, you're talking about two specific vectors, right? And there's two vectors here. There's a vector that is being pulled on. This is the handle, okay? And we know that this is 30 degrees. Okay, and they're pulling on this handle with some amount of force.
Mm-hmm.
And they're also, like, as they're pulling on this is moving over here with a force of 50 degrees. Sorry, of 50 pounds. So the magnitude of this vector down here is actually 50 pounds. Does that make sense?
Yeah.
Now,
Yeah.
what we want to know is, okay, if this thing is moving 50 pounds this way, how much force is actually being used with this handle? In other words, the handle is making it easier for us to pull this wagon. So the handle is helping us to pull this wagon because it's it's not going to use all 50 pounds. It's going to use a little bit less. So I guess the question is, how much force exactly are we going to have to use here? Now, it's different from the first problem because the force is being exacted in a horizontal direction. In the problem that I gave you guys in the video, the one with the sled, do you guys remember Billy and Bob on the sled? Billy was on the sled and the force acting on him was gravity. And gravity was acting on him with a force of negative 140 pounds, right? Because it was pushing him down. That's not the case here. We are not pushing down and we are not taking gravity into account. What's happening now is that we're saying that this wagon is going this way with 50 pounds of force. So I guess the question now is, what is the magnitude of this vector right here? How much force is being pulled on that handle so that this whole wagon moves with 50 pounds of force? I know that might be a little bit confusing. To answer this question, what we're going to do is we're going to go ahead and create a vector here. So we're going to have this vector right here, this red vector. And what I'm going to do is I'm going to project this vector onto this one to get my red vector. So I'm going to go ahead and project my white vector onto my blue vector. So I'm going to say the projection of the white vector onto the blue vector. Okay. Now, first of all, I need to figure out what my white vector is going to be. My white vector, how much is the white vector's vertical? What is the value of the white vector's vertical component? In other words, is it going up or is it going diagonal or is it going just horizontal? You guys please feel free to answer this. Like, think about it. Which direction is this white vector moving in?
Straight. Like,
You kind of cut off the review, so I didn't really hear what you said.
what do you mean? Like the wagon? Where's it going?
Yeah, like the wagon. Where is it going?
It's going right, no?
Yeah,
Is
it's going right, so it's going to be horizontal, right? And remember, component forms of a vector have two components. They have they have the vertical. Wait, actually, sorry, my bad. They have the horizontal first, and then they have the vertical because they have the x and then the y, and the x is the horizontal and the y is the vertical. So the horizontal component of this is going to be 50 I, all right? And is it going to have any vertical component? It's not. So it's going to be 50I, and you can say plus 0j because the j is the vertical component. Now, this differs from the from the sledding example because in the sledding example, we didn't have any horizontal. We had gravity acting on that sled in a vertical direction. So that's why in the sled example, we had a vertical component but no horizontal direction because gravity doesn't act on somebody in a horizontal way, only in a vertical way. So we know that this wagon is 50I plus 0j. And we know that this blue vector is going to be what? It's going to be the magnitude times the sine. Well, actually, sorry, for horizontal, we use cosine because it's x, times the cosine of 30 degrees, because we have a 30-degree angle here. And then it's going to be comma, the magnitude plus the sine of 30 degrees. Okay, so this is telling us that whatever our magnitude is, we're going to multiply times the cosine of 30. Now, the good thing about this blue vector is that because we're making it up, they didn't tell us how long this handle was or anything like that. And they didn't tell us exactly where I was pulling from. I can make up the magnitude. I can make this a unit vector. Unit vector, remember, has a magnitude of 1. That's what a unit vector means, that it has a magnitude of 1. And the reason that I'm able to do that is because, remember, what I'm looking for, my main goal is I'm looking for the magnitude of R. And the magnitude of R, it doesn't actually matter what the magnitude of B is because they're on that same diagonal, right? So the magnitude of R is what I'm looking for, so the magnitude of B doesn't matter. So I'm going to go ahead and say, well, then my B is going to be a unit vector. Why? Because it makes it way easier for me for my magnitude of B to be 1. Because now since this is just 1, well, then that means that I don't need to worry about this part right here because this is just 1. So 1 times the cosine of 30 is just the cosine of 30, and 1 times the sine of 30 is just the sine of 30. Does that make sense? I'm going to pause here, and I'm going to answer any questions that you guys may have. Just go ahead and unmute or type in the chat. It's fine. But
Do
I
you
want to make
always have to
If they never like give
times it?
the
Oh
slip
wait.
back,
Okay, wait, hold on. One at a time. Who was talking first?
Lauren.
I don't think it was.
Do you always have to times it by the cosine and the sine?
Yes, because that's the formula to get your component. So whenever they give you an angle, Lauren, it's always cosine times whatever angle they give you, and then sine times whatever angle they give you. And that was explained in the first video on vectors that we went over.
Oh, okay.
All right.
Mhm.
Vivi, what was your question?
So if they don't give you the magnitude, your magnitude's always going to be 1, you said? Or what was that?
You know what? Even I would say that even if they give you a magnitude, you can always make your magnitude equal to 1, because, like I said, the magnitude of B doesn't matter. This blue magnitude doesn't matter, because
Mhm.
what you're looking for is your R magnitude. And since B and R are on that same diagonal, then R is the only magnitude that's going to matter. So B, we're going to use it as an ends to the mean. The only reason that we need B on here is for this part, the angle part, because otherwise there's no way for us to put an angle into our equation. Does
Mhm.
that make sense?
Yeah.
Other questions? Okay, if there are no more questions, then we'll be moving on. Okay, now that we have both B and W for my blue vector and my white vector, I'm going to go ahead and plug it into my formula of the projection of W onto B. So remember, we're projecting W onto B, which means that we are going to form a right angle, a 90-degree angle with the tip of the white vector somewhere onto the blue vector. And this is going to form a direct right angle, and that's going to be the point where the red vector meets. So it's going to be like over here. So it's going to be all this. And again, we're looking for the magnitude of R. We're looking for how long that's going to be. So the formula is going to be, well, does anybody remember the formula? It's going to be the projection of W onto B is, I believe it's W dot product of B divided by the magnitude of B squared all times the magnitude of, sorry, not V. Sorry, not the magnitude, but the vector B, okay? So this is the formula that you're gonna use, okay? Now let's give ourselves some more room. There we go. So what we do now is we go ahead and say, okay, so we got this formula and we have the vector. So now all we really need to do is plug it in. First and foremost, W dot B divided by magnitude of B squared times B. First and foremost, let's focus on this part down here. Remember, the reason we made our magnitude 1 is because the magnitude of B is 1 and 1 squared is just 1. So it makes it very easy for us to just take this whole thing and just turn it into 1. That way we don't have to worry so much about everything else that's going on. This makes our life 1,000,000 times easier by making it just divided by 1. Now, what we have to do is we need to find the dot product of W and B. So the dot product of W and B, we got to go back to this. And the dot product, remember, is going to be the first terms multiplied plus the second terms multiplied. So 50, and we don't need to really mess with I and J anymore because they kind of serve their purpose. So 50 times the cosine of 30 plus 0 times the sine of 30. Okay? And so 0 times the sine of 30, well, anything times 0 just cancels out. And so what we're left with is 50 times the cosine of 30. Now, can anybody tell me what the cosine of 30 is? Because if you have your hand method and you know your unit circle, you should be able to tell me what the cosine of 30 is. Does anybody know?
Isn't it square root of 3/2?
Yes, exactly. The square root of 3/2. So what we're going to do is we're going to say, okay, well, this is, well, once we plug it into the formula, because this whole dot product thing, let's see. Oh, Saida, did you leave and come back? Hello, Saida. Wait, no. Zaida, why is there 2 of you? Is this a hacker? Zaida?
I accidentally got out, but
Oh,
yeah.
okay. Well, that's fine. I'm so scared of being hacked, guys. I'm gonna like cry if that happens. Not even gonna
You're
lie.
over
I would
paranoid
start laughing.
already.
Huh?
You're over paranoid already.
Yeah, I know.
I would start laughing.
Anyway, so this is gonna be the dot product right here. So in here is gonna go 50 times the cosine of 30. And we already said that the cosine of 30 was gonna be square root of 3/2, right? So square root of 3/2. So now what we have is we can go ahead, and since that's over 1, we're just going to get rid of that 1 because it really doesn't matter, because dividing by 1 is just the same thing. So 50 times the square root of 3 divided by 2, because we multiply these out, we put them together, which gives me 25 square root of 3/2 times b. And remember that b is this right here. It's cosine of 30 comma sine of 30. Now, if I wanted to, I could find the actual component form of vector r by multiplying this in here and distributing in here. That's what I could do if I wanted to do that. But am I looking for the component form of vector r, ladies and gentlemen? Yes or no? I want you guys to actually answer. Am I looking for the component form of vector r, or what am I actually looking for? Anybody? Mia, what am I looking for?
The projection B of W.
Yes, but I'm using this to find something very specific.
The
I'm looking for the what?
the magnitude of R.
I'm looking for the magnitude of r. So I'm not looking for the component form of r. The component form of r is some number I times some number, or plus some number j. That's the component form, right? It's the 2 values of r. And I could find the component form of r by distributing this into here. That's how I find my component form of r. But since I'm only looking for the magnitude of r, the magnitude of r is actually going to be this value that I got right here. Because if I were to go ahead and distribute this in here, then what I would get is I would get the formula for component form of r, which is magnitude of r times the cosine of 30, comma, magnitude of r times the sine of 30. This is the formula for finding the component form of r, which means that this right here that I'm about to distribute in here is actually the magnitude. So this is that point right there. So because that's the magnitude, and magnitude is the only thing that I'm looking for, then this is my answer. Now, it's not a proper answer yet because, you know, we have it in square root and a fraction. So if I actually wanted to find out what my answer is, hold on, sorry. I would go to Wolfram Alpha and I would go ahead and type in 25 times the square root of 3 all divided by, what was it, 2. Oh, wait, no. Sorry, not divided by 2 because we already divided by 2 because it was 50 and then we divided by 2. Yeah, that's my bad. So yeah, that's right here. When I went from 50 to 25, I actually already divided by 2. So it's 50 times the square root of 3 divided by 2.
So it's 43.3.
Yeah, that's the answer. So it's just this, 25 times the square root of 3, which is 43.3. So in other words, that's telling me that this handle, this 30-degree handle is allowing me to exert a force of 43.3 pounds, which is going to move my wagon with a force of 50 pounds. This is the answer for the second problem. I know it's not like one complete answer. I mean, this is the final answer that you should get, but that's not the only thing that I'm grading. What I'm grading is, do you guys have the work? Do you guys have the formula? Do you guys have the little picture drawn? That's what I'm going to grade. So when you guys submit your work, whether it's through a picture or whether it's through anything like that, just please make sure that that's all that you have on there. Like I said, I'm recording this and I'm going to go ahead and post it on YouTube, and I'm going to link you guys to it on Canvas. So if you guys do have questions, you know, it'll be on there for y'all. But at this point, if there's any questions, now would probably be the best time to ask them.
Sir, I got kind of confused when you were talking like about the cosine 30 and the sine of 30 under the 50 times cosine of 30 there.
Okay, so let me explain that really quick. Now, let's put this in a box and forget about it for a second. Let's go back to when we had a regular vector, right? And when I first talked to you guys about vectors, I told you guys that there was basically 2 ways to represent a vector. You could have it in component form, which is basically an x and a y, for example, like 2, 4. That's very, very thin. 2, 4, right? But there's also another way of representing vectors. And the other way to represent vectors is by telling you what its magnitude is and what its angle of direction is. So if I have this vector, for example. Okay. Now I can represent this vector as a component, or I could tell you that this is, let's say, a magnitude of 3. I'm going to call this vector v is equal to 3. The magnitude is equal to 3. And I'm going to tell you that the directional angle is around 125 degrees. Now, the question is, how do I get component form? How do I take this and plug it into there? Well, the way that I do that is by using the formula of my magnitude of v times the cosine of theta, comma, magnitude times the sine of theta. That's theta right there. So in other words, to find the component form of this vector, Mia, I would go ahead and take 3 times the cosine of 125 degrees, and I would also take 3 times the sine of 125 degrees. So that's why when we're focusing on this over here, I keep telling you that if I wanted to find the component form of r, then I would be using this formula over here. Magnitude times cosine and magnitude times sine. However, I'm not looking for the component form. I'm only looking for the magnitude, and the magnitude is what's missing from here, right? Because I have the cosine of 30 and I have the sine of 30, but I'm missing this magnitude. That right there, that's what I'm missing. Put it in white. I'm missing that piece right there. And that piece right there happens to be what's on the outside, because if I had something like, because I could easily rewrite this 3 times the cosine of 125. Oops, that's nasty. 3 times the cosine of 125, comma, sine of 125. And then all I would have to do is distribute that 3. But since I'm not looking for that 3, you could think of this like if I factored out that 25 times the square root of 3. And that's why that's my magnitude. I hope that made sense.
Yes, it did. Thank you, sir.
Cool. All right, other questions about question number 2 before we move on to question number.
So like basically all this is just like using our formulas.
You just need to know which way it's going, which is gonna probably be the toughest part. Which vector are you projecting onto which other vector? And are you moving in a horizontal direction, which means you're gonna use cosine, or are you moving in a vertical direction, which means you're gonna use sine? That's kind of like the tricky part to it. 1,780-pound car is parked on a street that makes an angle of 15 degrees with the horizontal. Find the magnitude of the force required to keep the car from rolling down the hill. Okay, so we have a street. Let's draw this. We'll use light gray. We have a street that creates a 15-degree angle. And we have a car, vroom vroom. That's a perfect car. That weighs how much? Well, this time we'll put this in red. The car weighs 1,780 pounds. So in other words, there's a vector of force acting on it, and this force is called gravity, that's acting on it with a force of 1,780 pounds. Okay? So the question is, find the magnitude of the force required to keep the car from rolling down the hill. In other words, what is stopping this car from rolling all the way back? How much force? And the force can either be applied with somebody literally standing behind here and holding the car, or it could also be applied by the brakes, right? The brakes are not allowing it to roll down the hill because there's a certain force or a certain friction required. So what you're going to do is you're going to, once again, you're going to make up a vector here, and we're going to make it a unit vector. That has a unit of 1, and then we're going to find the scalar. We're going to find the force that it would take to make this car roll down the hill, or the force that it would take to stop this car from rolling down the hill. They're going to be the same forces, right? The force that's going to take to make it roll down the hill, or the force that's going to take to stop it, is going to be the exact same. And of course, anything over that number is going to make it roll down, and anything under that number is going to make it stop. So what I would do is I would once again set up my 2 vectors, because again, I'm looking for the projection of which vector onto which vector. I'm looking to project red onto green because I want to know how much this force is going to take. I want to know what this blue vector is going to be. The blue vector is going to be the actual force, right? Right now I have that green vector. That's the one that I'm going to make up, but the blue vector is the one that I'm looking for. So I'm going to try to project red onto green. So I'm trying to project red onto green, which means that I'm going to use the formula, the dot product of red and green divided by the magnitude of green squared. I don't know why I drew that. Times the component form of green. So times the component form of green. Now, once again, am I looking for the component form of green? This whole thing, what it's going to equal is going to equal my blue vector. That's what I'm looking for. It's going to equal my blue vector, but I'm not looking for my blue vector. I'm not looking for the component form of my blue vector. I'm only looking for the magnitude of B. So I'm looking for the magnitude of my blue vector, not my component form of my blue vector. This formula gives you this, but as a byproduct, this part right here is actually going to give me my magnitude of my blue vector. So all you need to do is you're going to project this vector onto this vector. I guess that's kind of terrible. To form a perfect 90-degree angle would be something like this. That's kind of like 90 degrees. And then you would find the magnitude of that blue vector. Nico, how are you feeling? Do you know what your next step would be?
From here you'd find like the cosine and sine thing, right?
Mm-hmm.
Okay. But
So
then what would you use as like the cosine and sine? The 15 degrees?
yes. So for your red vector, remember your red vector has both a vertical and a horizontal component. So tell me, does the red vector have any horizontal component? Yes or no?
That's the vertical.
Exactly. So it has 0 horizontal eyes plus how much vertical?
1780.
Yeah, and you could say it's negative 1780
Oh, because
because
it's going down.
it's going down, right? Although that honestly isn't going to matter that much in the end. But for right now, let's say it does matter. Okay.
Okay.
So what you're going to have is your red vector is going to be 0i minus 1780j. Now the green vector, oops. Now the green vector, again, we're going to make my green vector, we can choose whatever we want as its magnitude. What magnitude should we choose as for the green vector?
1.
1.
Yes, we want to choose a magnitude of 1 for my green vector. So my green vector is going to be a unit vector. That's going to make my life a million times easier. So because it's a unit vector, the formula for this is just going to be, sorry, not sine, because x is cosine. So it's going to be the cosine of 15 degrees, comma, the sine of 15 degrees. And then from here, I would plug both of these things into my formula. And I think that's where I'm going to leave it for you guys to figure out the rest, okay?
Okay.
Other questions, guys? I'll have you know that the quiz that I'm going to post later tonight I'm gonna make it due on Sunday, so you guys are gonna have tomorrow to do it, but you guys are also gonna have the weekend. Um, it's not gonna be a long quiz, and it's gonna be using the practice problems that I gave you on there. So I gave you a sheet full of practice problems, and those are the problems that of the questions of what they're gonna look like. Okay, so they're not gonna be too difficult. And if you guys have any questions on those, then you can just shoot me a message, and I'll go ahead and answer them. But I hope that this was helpful. I hope that you guys have a better understanding of the projection and magnitude of vectors. I'm going to be honest, it took me a while to figure out a way to explain it so that it made sense. Because, you know, when you understand something but you can't really explain it, it was hard. And so I'm hoping that this helps. But if it doesn't, then I completely understand. And I just ask that you guys message me, and hopefully I can explain it to you guys in a different way. I'm also going to send you guys that video that I talked about in my other video, because that other guy did a really good job at explaining it. He's got a whole lot more views than me, so he must be better.
Mr. Buceta, I have a question.
Yeah, Nico, what's up?
What would be your like formula thing for like the red and the green thing? Like in order to put it in the projection form.
It's already here, Nico. It's that thing in white. That's the formula.
No. But like, how would you get that? Because I know it's like so it would be 0i like plus or no times cosine 15, right?
Yes. So you multiply these. So you multiply this and this, but 0 times cosine is just going to be 0, right? And then you're
Right.
going to get negative 1780 and times the sine of 15. So
And then
this is
you
what
would add those together, correct?
you're going to multiply them. You're going to
No,
multiply these two, this times this, and this times this, and then you add these two together. That's right. But
okay.
since this is 0, then you're not going to have anything.
Okay.